Hello again. As you conclude a content inventory and audit in your work toward a content strategy, it's time to create content models. To help you understand how this works, including its relevance to content management systems or CMSs, I'm going to cover 3 topics in this video lecture. I'll start by explaining why content modeling is needed for both TECM and MARCOM content. Then I'll describe 2 levels of content modeling. I'll begin with a sample at the micro level and talk about structured content. I'll conclude with a sample at the macro level and talk about information architecture activities like taxonomy and metadata development. All right, let's get started. We begin by helping you understand why content models are needed, especially in the digital landscape. Let me say just a few words about content management systems, or CMSs, at this point. The connections made possible by the internet meant people could share content worldwide. Everyone could publish content. Content management systems like WordPress arrived in the early 2000s. They made it possible to publish content with little, if any, knowledge of coding. Things have come a long way since the early 2000s. In order to explain why content strategists need to model content, I need to show you how content is currently being used. Imagine that an organization has some print instructions for assembling their product. They might want to make all that same content available to customers or customer support on a desktop computer. They might also want just this chunk of text to be available to customers when they access the assembly guide on their smartphone. And they might want an even smaller chunk of content to be available as audio on Google Home or Alexa. How do they make that happen when the content in the print guide is in Adobe InDesign? They could pay employees to recreate the same content in different applications so that it appears in all these different channels. I hope you recognize that sounds highly inefficient. They could also use a special type of content management system that stores the content in a way that allows it to be pulled into different delivery devices with different designs. Even though they may have to pay extra for that kind of content management system, it'll probably be worth it if they have enough content and they see content as an asset to their business. There are several ways industry talks about this type of content delivery. In TECM, it's been called single source publishing. It's done in a component content management system, or CCMS, that allows content to be reused. Those CCMSs include products like Madcap Flare, Adobe RoboHelp, ClickHelp, EasyData, and others. In larger enterprises, tech writers have been using these tools since the early 2000s. In marketing, the way of delivering content in chunks is sometimes called COPE, for Create Once, Publish Everywhere. It's also talked about as multi-channel or omni-channel publishing and is done in a headless content management system, or a DXP. That stands for Digital Experience Platform. This idea is newer. Many marketing folks still use a content management system or CMS like WordPress or Drupal for web publishing and separate tools for other channels like social media. DXPs are just beginning to be adopted by larger enterprises for their entire marketing function. CMSs have developed in many different directions in the past 2 decades. Deciding what CMS to use is a very complicated decision now. I'll return to this point a little later in this lecture. For now, it's just important that you understand what a content management system does, and that there are specialized types like CCMSs and DXPs. Let's think about how one of these systems would have to work in order to make single sourcing or multi-channel publishing possible. The key is that content must be stored in reusable chunks instead of in documents or pages or whatever. Those chunks have to be findable by either humans or machines in order to get used. That means each content chunk needs descriptive information that helps it get found. It also means that commonly produced documents, like, let's say, a product assembly guide, needs descriptive information that tells people or machines what type of chunks of content are needed within them. This is where content models come in. At the micro level, each genre or content type is modeled as composed of content elements within a defined structure. At the macro level, all content chunks are modeled by grouping all those types and describing them with their attributes. Then a taxonomy and metadata are created. I'm going to talk about these in a little more detail. Let's start by describing what a micro-level content model might look like. While we can't get into great detail about information architecture or IA, I do want to help you think through the steps in the process of modeling content the way it's typically done in IA. Some of these IA steps should be familiar to you at this stage of the content strategy course. For instance, it begins with a content inventory where you locate and identify all existing content. The second part is an audit where you evaluate that content for things like engagement or usefulness or consistency of tone. I'll talk about the other steps in the third part of this lecture. For now, I want to get you to think about how you might conduct content modeling at the micro level after step 1 in the process. Imagine you were helping Blue Apron with their content strategy. You have a spreadsheet with a list of the content assets on their customer website. One of your tasks would be to identify the different content types Blue Apron is creating. If you look at the part of the inventory spreadsheet I'm showing you here, you'll see I've identified a type for each asset. Here's a recipe. Note that there are several other recipes. I've noted these assets are all the same type. I've also identified content types like landing pages. This type of content is where the user goes when visiting different categories of information on a website, like the sample recipe page or Meet Our Partners page. In all, in this sample, I found 10 different content types. 1 home and 5 other landing pages, 7 partner pages, 7 recipe pages, 4 catalog pages, 4 legal pages, 2 corporate pages, 1 customer account page, and 1 customer login page. What I need to do is develop a content model for each of these 10 types. Let's take the example of a recipe content type. A recipe can be chunked into a collection of elements. I'm going to show these in a simple XML format. I'll just mention here the reason XML is often mentioned in job ads for technical content creators is that component content management systems normally use XML. The tagging should look familiar to you as it's quite similar to the tags used in HTML. But in XML, those tags are semantic. They're about meaning, not format. So, for every content type, we have to recognize what types of elements are common to all instances of that type. For example, all recipes need a name. They need ingredients. They need instructions. In our model, we can ensure that every recipe has content for instruction. It's a required element. And maybe also that instruction elements must always come after ingredient elements. We probably need more elements to accurately tag ingredients, like item, its quantity, its preparation. We can decide that every ingredient must have content inside the item and quantity tags, but make preparation content optional. We might want to add elements like recipe type that categorize the recipe content type into subtypes. We might also want to capture elements or attributes that aren't specific to recipes, but would be useful for many content types, like author. This brief example, which I borrowed from the folks at Scriptorium, who published a great white paper on something called structured authoring and XML, should give you a sense of how the content can be structured as chunks of data within a database. This is what TECM pros mean when they talk about structured content. As I said a little earlier in this lecture, deciding what CMS to use is a very complicated decision. In part, that's because every CMS operates with content type models, although users might not know that. For example, when you create a new page in a WordPress.com site, your page automatically populates with a title and a paragraph block. Those are the default elements in every page created with WordPress. Now, it's true, WordPress allows you to pick from templates when adding a new page, but these templates focus primarily on layout or design, not on content types or their elements. WordPress.com does now have an option to create reusable blocks that can be inserted in multiple pages or posts, but it's primarily a page-based content management system. Unfortunately, a content strategist is going to need a more sophisticated tool to make content chunks into structured content. For example, the headless CMS called Content Stack has users create a content type before creating any actual content. The fields selected by the content creator become the elements in a model of the content type. Similarly, the component CMS called EasyData implements content types based on the standards that are called DITA for Darwinian Information Typing Architecture. A concept is a specific DITA content type that has several required elements, and EasyData allows users to add optional elements or attributes to specific content types as well. Did I mention that deciding what CMS to use is a very complicated decision? If you're interested, Dean Barker published a book titled Real-World Content Modeling, a field guide to CMS features and architecture in 2019. The details are found in the instructional materials on Canvas. Before I move on, I'll mention 4 advantages related specifically to structured content. First, content is totally separate from its design or any specific channel. We can make all ingredients appear in a specific style dictated automatically by whether it's being viewed on a smartphone or desktop, for example. Second, content is created once and published everywhere. Remember, COPE. Third, content can be searched easily by users and by other content creators because of the elements of structure associated with each content asset based on its type. For example, by finding all of the cake recipes. Fourth, content creators need less training and oversight by editors because the content model, in other words, the required elements for a content type, are enforced during creation in a CMS. Every writer must add quantity for an ingredient in a recipe, for example. Now that you understand a little about how content modeling applies at the micro level to individual pieces of content, I want to describe how a content model applies at the macro level of, for example, a website. A complete content model tells you how all of your individual pieces fit together. Think about a print cookbook. Readers can find an angel food cake recipe by using tools like the table of contents. Creating a table of contents requires a model of the content in the cookbook. In other words, the collection of recipes has been sorted into categories. The standard would be to do that by dish type: appetizer, entree, side dish, dessert, and so on. Because those categories might not meet the needs of every reader's search for a recipe, books also have an index with recipes categorized in different ways, alphabetically, by main ingredient, or could be something like geographic cuisine. If we're talking about the web, you might start looking for a recipe on a specific site with navigation aids, something like a table of contents. On Blue Apron's site, you see navigation aids on the left that function somewhat like a table of contents. In 2014, Nielsen Norman Group published an article about the difference between IA and navigation. This is important to grasp. Let's say Blue Apron used their table of contents from a print cookbook to create the navigation on part of their website. That content model isn't going to be adequate for all users looking for recipes or even for all of the content on their website. Instead, they need the kind of model an information architect would build before designing the navigation. As Nielsen Norman Group said, IA is documented in spreadsheets and diagrams, not in wireframes. We need to consider the third step of IA, which involves information grouping, where you describe the relationships between pieces of content. As I said earlier, all content management systems treat content as data. To build a model of all the digital content in a complex organizational website like Blue Apron's, it's a huge undertaking. Let's look at an information grouping of some of Blue Apron's customer-facing web content. You'd start with a spreadsheet containing the results of the first two steps that produced a content inventory and audit. To describe the relationships between the pieces of content, we'll draw diagrams to represent what's in the spreadsheet. Ideally, we would involve Blue Apron's users in this step. So, this gray box represents the information type menu, which is in green highlighting. By looking at the content inventory in the spreadsheet, we see menus have 5 attributes. Those are shown in white. Meals, that can have 2 values, 2 a week or 3 a week. Servings, also 2 values, 2 people or 4 people per meal. Pricing, which can be signature, premium, or vegetarian. Date, which can be an actual calendar date as well as current week or upcoming week. And recipe, available based on the other 4 attribute values. We continue grouping information shown in our spreadsheet into info types and develop some others. Ingredient, technique, supplier, wine, marketplace, and of course, meal. This isn't a complete model of information groups, but it should be enough to get the idea. Some info types appear as attributes in other information types. For example, wine is an attribute of marketplace and recipe. But wine is also an information type of its own and has its own attributes or values. In our model, we show that wine is related to marketplace and recipe by connecting our boxes with lines. Once we've grouped our information, we can begin step 4 of the IA called taxonomy development, where you define naming conventions to apply to all the content. Taxonomy is an entire discipline, so I'm not going to do it justice here. Think about all of the information types and their attributes listed on just the previous slide. One of the most important goals in step 4 is to create a controlled vocabulary by choosing preferred terms among synonyms. For our Blue Apron content, we have to decide. Will we refer to a whisk as a tool or a utensil? We also have to choose how terms relate to one another in hierarchies. Will fish and shrimp be labeled as seafood, or will fish and seafood be separate categories? We'll want all of our content to be consistent, to be meaningful to our users, and to fit our voice or brand. Once we've developed a taxonomy, the 5th and final IA step involves metadata creation to help users discover content. Here's what I created in step 3 for the information type wine. For Blue Apron, it has 7 elements or attributes. Knowing something about how Blue Apron's users search for content, we could decide we want to explicitly use either these attributes in white or the actual values for those attributes that are in specific instances of wine. That's what's shown in black in these green boxes. Not only will we determine which terms should appear in the actual written content, but we'll also want to determine when to use them as metadata, which can be included explicitly within the content on published pages or hidden behind the scenes in code by entering them into form fields in our CMS. Either way, it helps users find the content they want on Blue Apron's website, and it helps fellow content creators find it in the CMS. All right, I've covered a lot of ground here, and I know much of it will be new. So let me take a second to summarize the main points. To make single sourcing or multi-channel publishing possible, content must be stored in reusable chunks instead of in pages or documents. Those chunks have to be findable by either humans or machines in order to get used. That means each content chunk needs descriptive information that helps it get found. It also means commonly produced documents need descriptive information that tells people or machines what type of chunks are needed within them. CMSs differ greatly. All operate with a micro-content model, even if it isn't explicitly mentioned. Many, if not most, do not truly support reuse and multi-channel publishing because they're page-based rather than component-based systems. All right, so content models provide detail about content. At the micro level, each content type is modeled or composed of elements within a defined structure. The content strategist can begin this work when the inventory of content assets is complete. You might simply add another sheet to your spreadsheet to list the required and optional elements needed for each content type. At the macro level, all content chunks are modeled by grouping them and describing them with their attributes. This is best done in diagrams. Then a taxonomy and metadata are created for all content. The content strategist must wait until the future of all content assets has been determined before starting macro-level modeling. Otherwise, they might waste their time on content that is going to be archived. The taxonomy and metadata can also be documented in a spreadsheet. Ultimately, your CMS must provide you with a way to implement everything about your content model. While content modeling represents a lot of work, it's important to keep in mind that it's a prerequisite for any organization that wants to reuse, personalize, or publish content to multiple channels.